The Square Kilometre Array is the next step in radio telescope technology. It will have up to 50 times the sensitivity of current radio telescopes and will survey up to 10,000 times faster. Research collected from the Square Kilometre Array will revolutionise our understanding of the universe and fundamental laws of physics. Australia is currently in a bid against South Africa to host the Square Kilometre Array. Dr. Martin Bell from the University of Sydney is currently part of a research team working on the precursor to the Square Kilometre Array.
The name, the SKA, means a square kilometre of collecting area. So if you sum up all of the area that you can collect over this huge area, it forms one square kilometre, which will be the largest telescope we've ever built and sort of conceived. So the main overview of the SKA is that it is a next generation radio interferometer, which is a type of telescope. These types of telescopes, instead of just having one main telescope, they have many arms and dishes involved within the telescope, and all the signals from those dishes are combined together to produce an image of the sky. The main topics are galaxy evolution and dark energy. So the other one's testing relativity, testing general relativity by studying black holes and pulsars. The other one is the dark ages, studying a time before, when the universe was just cooling down and starting to form stars, and then started reionizing the local environments. And the last one is searching for life within the universe. So searching for signals from other planets.
CSIRO scientist Dr. Alana Fain is interested in the role of black holes in the creation of galaxies.
What I want to know in my area of research is just how important black holes are in the formation and the evolution of massive galaxies throughout the universe. We simply can't answer that question now because we don't have sufficient sensitivity or sufficient resolution, in fact, to image these black holes, and there are black holes in every galaxy in the universe, but to image them out to cosmic times close to the Big Bang, to have a look at what black holes look like in the distant universe.
Dr. Karl believes that all Australians have something to benefit from the research generated by the Square Kilometre Array.
There will be magnificent flow-ons to the human race and to Australia if we get the project, in terms of getting an educated workforce, a technologically skilled workforce. The thing about doing pure research is you don't know what it'll get you. So with regard to Albert Einstein, in 1905 he comes out with his theory of relativity. Nobody has any idea that a century down the line it'll help slightly inebriated people on a Saturday night navigate their way to a pizza bar to get some saturated fats, in other words GPS. Nobody knew that GPS would come from Albert Einstein. About 30 years ago you got some scientists looking for black holes. Nobody knew that it would give us Wi-Fi.
If Australia is successful in the bid, the radio telescope will be based out at the Murchison Radio Astronomy Observatory in Western Australia, as well as across New Zealand.
So the advantage of the Murchison Radio Astronomy Observatory is that it's in an area of Australia that has very low population, and so there are much less the usage of microwaves, phones, and any other construction equipment that could produce signals in the same bands as the SKA operates. It's minimised, and also it's very geographically suited to hosting lots of different antennas over several hundred kilometres. So it's very flat, and the weather is very stable weather patterns as well.
The results of the bid are expected to be announced in mid-May. Jessica Looi reporting.